We see color every day in our lives. From animals and plants to everyday objects and buildings around us. Color literally colors our lives. Do you ever wonder how you can see color in the first place? Why do some objects appear colorless and others are not? And how light plays a major part in it? In this video we are gonna explore the science of color. The color does not come from the object, but rather the light that is reflected or transmitted from the object. You probably remember from science class that light is an electromagnetic wave. The light we can see, which is visible light, is part of what is known as the electromagnetic spectrum, which is the range of frequencies of electromagnetic radiation. However, the light we can see is just a small part of this spectrum, around 400 to 790 terahertz or 380 nanometers to 760 nanometers. Anything above or below that cannot be viewed by us. White light is just a mixture of all species electromagnetic radiation of equal intensity from the visible light part of the spectrum. What we see is the color of the object depends on how matter behaves when light hits it. So we know that everything is made of atoms, and atoms inside them have electrons. Every substance has a specific number of atoms and electron configuration. So when light hits the substance, a couple of things can happen. One of them is reflection. When you shine light, free electrons in the substance absorb the energy from the light and vibrate. After that, the electrons release the light energy at the same frequency. The next is absorption. It is when the incoming light frequency is the same as the electron's vibrating frequency. The electron absorbs this light energy. During its vibration, the electrons interact with neighboring atoms in such a manner as to convert its vibrational energy into thermal energy. Subsequently, the light wave with that given frequency is absorbed by the substance, never again to be released in the form of light. This is what makes objects appear opaque. Transmission is when the incoming light energy is much lower or much higher than the vibrational energy of the electron in the material. Here the light source will pass through the material unchanged. Lastly, we have refraction. It is similar to absorption in the sense that the incoming light energy is the same as the vibrational energy of the electron. However, in this case the light can travel further into the materials and interact with the electrons there. The electrons will vibrate at the same frequency as the light and pass on the vibration to the other atoms. This caused the light to appear bent in the material. The human eye and brain translate reflected light into color. Light receptors within the eye transmit messages to the brain, producing the familiar sensation of color. The retina is covered by light-sensitive receptors, which are rod and cone cells, and it's these receptors that process the light and then send this information to the visual cortex. Rods are mostly concentrated around the edge of the retina and transmit mostly black and white information. Cones transmit the higher levels of light intensity that create the sensation of color and visual sharpness. These cells working in combination with connecting nerve cells give the brain enough information to interpret and name colors. Why do some objects appear colorless? These objects are transparent. Light passes through the object with very little reflection of light. So next time when you're watching TV and looking at all the pretty images, realize there's a lot of things going on that allow you to see those colors.